All right, good morning, everyone. My name is Chad Holdorf. I'm the track chair for the enterprise track. I work in a company called John Deere. Hopefully a few may have heard of it. Today we're up to around 300 plus Scrum teams. A lot of them working on embedded systems, some of them working on desktop, mobile, and a little bit in between. Kenny and I've had lots of conversations since 2010, something like that. We've at John Deere always have the debate about components versus feature teams. How do you form them? When we first got started, we had 100 teams that we jumped in all at once. We didn't feel like doing a team by team was going to be really that effective, so we decided to do 100 teams at once. So trying to figure out how you figure out your structure for each of those teams was not an easy solution. It's still not an easy solution today, but today we're probably 70% feature teams, 30% component teams. And I still reference a lot of Kenny's stuff, so he'll let you use it and just give him some recognition, and you'll get some good stuff. So let's give a big round of applause for Kenny.
Thanks, Chad. Good morning, everyone. Thanks for being here. You can download the slides that I'll be using in this presentation at that URL right up there. And as you can see by that page, I'm going to give away a copy of my book, Essential Scrum. At the end, whoever does the most useful tweet about the content of the session, and all you have to do is include my name on there so I can find it, and Agile 2013. So, yeah, the discussion here is really about how to scale with feature versus component teams. I'm going to jump right into this. And how many people were in my session on Tuesday? Oh, okay, welcome back. There's only like one slide that overlaps with that session on Tuesday, so most of this is all going to be new stuff. Just the one slide background, as Chad said, I've worked with him at John Deere. I work with a lot of companies. I'm a trainer and a coach, and so I spend my time going around helping companies adopt Agile and teach Scrum and Agile classes. And so I hope when I talk to you today, I'm going to be drawing from the experience I have having visited a lot of these companies, because each week I'm typically with one or two different companies somewhere around the world doing this kind of stuff. So I'm not going to go into a lot of detail on my background. I want to get right into what we need to discuss. Let me start right here. Here's the entire Scrum framework in one picture. I'm going to spend like 2 minutes on this just to set a foundation for our discussion about what's coming. All right, so this is a really simple picture because it's assuming we have one team and one product backlog, right? And how does it work? Well, we have our product owner over here on the left. Sorry if you're a product owner, I didn't mean to imply you had a comb over, but we have our product owner here. The product owner's got this great vision, right, for what they would like to build. Think of that as the blue cube that they want to build. It's pretty grand, so they can't build it all in one short duration sprint of perhaps a couple weeks up to a month. So what do? We break down that vision into a set of features. Think of this as like the blue bricks. The blue cube becomes the blue bricks, and we put them into a prioritized list. We'll call that the product backlog. The process by which that takes place, we might refer to as product backlog grooming, right? Things like writing and refining, estimating, sizing, sorting them, prioritizing them. And then we start sprinting. The gray looping arrow that dominates the center of that picture is intended to be a sprint, and the first activity in any sprint is the planning activity, the goal of which is pretty simple. Pull some number of ready features off the top of that product backlog into the current sprint based on available capacity. Those two orange arrows here are trying to define a capacity, and we pull till we get to some reasonable WIP limit associated with that sprint, and then we stop. And that becomes the focus for that sprint. Most teams consider creating a sprint backlog, which takes those features, breaks them down into tasks with the goal of trying to acquire confidence. Are we confident we can get this done? In any slide I put up, if you see something that looks like a blue brick, it's a product backlog item. If it's a green cube, it's a task. Design, build, test, integrate, work. The darker gray shadowing on the arrow, that's roughly how much time you would probably spend in that activity in a given sprint. The majority of the time is going to be spent in sprint execution, where we actually do the design, build, test, integrate work. Every day we do a daily scrum. The goal, produce a potentially shippable product increment. We weren't trying to produce the entire blue cube in this sprint. We were just trying to produce a piece of it. Couldn't produce the whole thing. It was too big. But the piece that we produced should be done to some reasonable definition of done. And then the last two activities, both inspect and adapt. The first is the inspect and adapt on the product, sprint review, and then the inspect and adapt on the process, sprint retrospective, and then come around and do it again. And of course, after you've done that a sufficient number of times, you likely do have the blue cube, and that would be what you would deploy. Nice and simple. One team, one backlog, everything works really quite smooth. I bet a lot of us have been doing this for a while, probably functioning just fine. What if? All right, let's take this to the next step. We're going to be talking about teams. So I feel compelled to give you a description of what I think would make for a good Agile team, right? A good Scrum team, perhaps. Here are the characteristics I would look for. First is that I think we're familiar. Teams are supposed to be self-organizing, meaning there's no manager, there's no Scrum Master that stands behind the team telling them what to do. They're supposed to figure that out on their own. So we give them a clear elevating goal, and they organize around the work to figure out the best way to solve the problem. Who's on the team? Well, you have to have the skills that are both cross-functionally diverse and sufficient. In other words, all the skills necessary to get the job done. If you're lacking an important skill, then you haven't adequately staffed your team. I would like teams with T-shaped skills. The metaphor being this, right? T-shaped skills. I expect everybody on the team to be vertically deep in some specialty area. You know, if you do QA, then testing would be your vertical specialty. If you're a developer, maybe developing is. But wouldn't it be nice if there was a little bit of breadth to the skill set of the people on the team? So yeah, I might be vertically deep in testing, but I can help out on some of the UI work, right? I can do some database work. I'm not a DBA, I'm not a UX person, but I can help out in those areas. And if I had people with T-shaped skills, if I ever had an overabundance of work in a given vertical area and only had one person who could work in that area, then obviously I could run out of capacity during that sprint. If I have people with T-shaped skills, it enables the behavior we want, which we can call swarming. Those people could swarm onto the area of too much work and relieve the bottleneck. So I'd like to staff my teams with people with T-shaped skills because that'll also help enable a musketeer attitude. You know, all for one and one for all. I mean, the whole point of a team is that we're in the same boat. We win or we lose as a team. I mean, it would be like going out on the water in a boat and me saying something like this to you, wow, what a shame. It would appear that your side of the boat has sprung a leak. No, why are you laughing? My side's dry, you have the problem. Yeah, I'm thinking in a couple minutes we probably share this issue. We have to realize we are actually in the same boat here. Musketeer attitude, please. High bandwidth communication. I'm not talking about do you have good internet connectivity to your distributed team members. That's implied. I mean, have we gotten the unnecessary formality out of the process so that the team members are able to communicate with each other in a high bandwidth way? Transparent communication. How do you inspect and adapt in an environment where you don't freely share the information? It'd be hard to improve. Right size. Well, I think most people are familiar. The average team's supposed to be, on average, 5 to 9 people makes for a good Agile team. It's a guideline. It's not a law. You can have smaller teams, you can have larger, but it tends to be the sweet spot. Focused and committed. You ought to be thinking right now of how many teams do you ask people to work on? Or how many different projects do you assign to a given team? Are they able to really stay focused and committed when you do that? Working at a sustainable pace, can't burn them out. And long-lived. In Agile, we favor long-lived teams. The economics favor keeping teams together for an extended period of time. If your company's attitude is at the end of every project, we're going to blow away the current team and dynamically compose a new team for the next project, you'll lose the benefits of having people who have worked together and understand each other, trust each other, have their backs in a hot situation. You won't have that. Plus, you won't have any shared estimating history, any shared velocity, which will make planning a bit more difficult. So I want my teams to look like this. But now I want to scale it. I'm curious. So I'm going to ask you to take a moment or two, talk to your neighbors, and answer that question. When one team is no longer sufficient, how do you scale? So just take a moment, chat with your neighbor, see what they say about this, and then we'll see what you come back with. All right, I'll tell you what, let's come back together. My guess is you could continue that discussion for the next hour. Let's see how many of these patterns you guys have. All right, so hang on a second. I'm going to walk through them, and when I get to each one, raise your hand if this is the one or if this was included in the list of strategies that you talked about. I want to talk about some patterns you might have discussed right, in that little discussion you just had. Discipline-specific teams. So let's organize our people by discipline. So, have all the QA people on one team, have all the developers on another team. Scaling, who had that as their strategy? A couple folks, all right. Do it by location. Look, I have some people here in the US, I have some people in India. I could choose to form a team that was just based in the US and, of course, have the other team based just in India, or I might consider sort of deliberately distributing the people across both. So location-based teaming, a bit more, right? People at that level. Okay, fair. Architectural teams, do it by architectural layer, right? So here's our database team, there's our middle tier team, there's our GUI team. Oh, even more on that one, okay. Component teams. Now, let me define this because I found that sometimes it's not exactly clear what I meant by a component team. So I'm giving you an example here. When I go into Costco and I buy a GPS, I buy a device that gives me audio and visual turn-by-turn instructions on how to get from point A to point B. I didn't buy a routing component. I'm pretty sure there's a routing component in the GPS, but that's not what I went to buy. I buy features. I bought the GPS. Routing in the context of a GPS might be considered a component, right? And that component probably gets reused across multiple different GPSs by the same company. So who forms teams based on components? Oh, a bunch more hands going up at that point. All right, so those are component teams. Feature teams. Now, a feature team, just to be clear on the definition, here are features in the backlog. Remember, that's like we took the blue cube and we broke it down into blue bricks. Here's our features. A feature is something of value to your customer. If I showed feature A to your customer, I go, what do you think of that? They might go, yeah, I'd pay money for that, or that and these things together, that would give me money. So teams that build features. Even more. All right. Did I miss any? Anybody have a different team structure they discussed? Please.
What happens when feature A and feature B want to share a common component in the routing algorithm in your GPS?
So what happens when two teams want to share a routing component? Two features want to use the same component. That's the nature of our discussion we're about to have. Right? I mean, these are the obvious things we have to deal with when talking about how to structure teams. Please.
The other strategy is to grow the team to fit the work.
So keep adding more folks to the same team. Anybody here work on a team larger than 10 people? Keep your hands up if it's larger than 15. Meaning on the same, you would consider them to be members of the same team by however you're defining a team. More than 20. Uh-oh. All right, 25? All right, how big?
When I first got there, we had a team of 50.
5-0?
5-0.
So a 50-person team, right? Look, I think we all understand the rule in Scrum or in Agile in general for having small teams is based on a number of factors. One is the obvious that the communications channels go up by the square of the number of people. Right? The formula is n times n minus 1 over 2. So doubling the number of people doesn't double the number of communications channels. It goes up by the square. Plus you enter into something called social loafing. What's my motivation to really kill myself on that? There's 49 other people on the team, right? Someone else will probably pick up the slack.
Why do you guys put your finger in a hole on the other side of the boat?
Right. You go plug it up. I'm sitting kind of dry over here, right? Yeah, so you don't want to have that happen. By the way, on small teams, there's really no place to hide, right? Please.
Teams that own, in companies that have a lot of service-oriented architecture, microservices, those kind of things, are those, and teams that own those kind of services,
Mm-hmm.
would you call those component teams mostly, or feature?
They're likely going to fall under the definition of component team, but I'll need a little bit more foundation before we can reach that conclusion. Please.
We have teams which are based on projects. So project start, it goes to multiple teams. So would you call them as a feature, as a project? Once they're done, it's over, and then new project is a different team.
So the question is, you have a project and the project has multiple teams on it. Would you consider all those teams, one feature? Now, what I'm really talking about is for any endeavor, product or project, you choose your favorite word, right, in that context, and you need more than a single team, let's say we won't use 50 people on a single team, then the question is, how do you go about deciding what types of teams, based on the variety we've been discussing, it makes the most sense to put into place? That's the entire purpose of this discussion. Let's take a little further. All right, we've just talked about, right, some of these. Let's go into it in a little bit more detail. The way I approach this problem is the following. I use the economics of the choices to make the decision. How else could you possibly do this? Right, so I'm going to talk about economically sensible scaling, not dogmatic scaling. See, I think the dogma in the Agile industry reads like that. Everyone knows feature teams are better. Nuts. You know, component teams promote conceptual integrity and reuse. You got to have those. If I don't have a team owning the routing code, isn't it possible someone will go in there not knowing in the world what they're doing and screw the whole thing up, and all the GPSs will start to fail? That's the argument on the side of component teams. The question you have to really ponder is that. Do you really think there's one approach that will universally work across all organizations, all types of products or projects, and just will be the definitive answer in all cases? I mean, come on, that fails the common sense test. So we need a framework for making a decision. By the way, there will only be trade-offs. I can't tell you there will ever be truly an optimal answer. Every solution we discuss will have its pros and its cons, and your goal is to find the one that makes the most economic sense in the context in which you're trying to do it. All right, if we're going to set up an economic framework, then we have to be prepared to talk about these trade-offs, right? Because sometimes when you choose a particular structure, in this context I use the term system, I don't mean a product. I mean the way in which we organizationally organized our teams to flow the work, right? That's the system I'm referring to, right? The organizational system in the structure of the teams. Well, sometimes we can organize and we have better or worse waste characteristics, or sometimes we can get things done faster, other things will take more time, variability, efficiency, reuse. The problem, though, is all those variables are in different units of measure. And it's hard to make trade-offs if someone goes, well, if we organize it this way, it'll cut waste by 5%, and if someone else says, but if we organize it this way, we'll get 20% better reuse. Which was the better choice? Until you can compare them in some sensible unit of measure, you're just guessing at that point. I don't know, is 20% reuse better or worse than a 5% reduction in waste? So I'm going to borrow something from Don Reinertson, which is focus on lifecycle profits, meaning map all of the proxy variables into lifecycle profit space. Make all decisions in the same unit of measure. That way you have a very simple way of comparing, is this better or worse than this? And not by saying, I don't really understand the difference between reuse and waste, by converting both reuse, waste, and all the other ones into lifecycle profits. And then we answer the question of which of the proposed solutions for how to structure the system, the teams, and organize them, gives us the best flow through the system, the fast, flexible flow in an economically sensible way. That's the solution you want. The goal by the end is to figure out, how do we make that decision? So I can't answer the question for you in your organization, what's the best structure? My goal for this discussion is to lay out a framework that when you apply the framework will help you answer your own question. That's the goal. I want to show a couple of these variables because they're important in our discussion that's coming. Waste being an example. I mean, everybody's interested in eliminating waste. That's a given. The problem, of course, is that there are multiple forms of waste, and it's typically impossible to eliminate all forms of waste simultaneously. Frequently, when you eliminate waste, as one waste goes down, another waste goes up. And unless you know the economics of those wastes, you don't really know which was the better waste to have gotten rid of. And the real problem is, in most organizations, they focused on the wrong form of waste, especially in software product development. Right? And is it not true? In software product development, the largest cost associated with product development for software tends to be people. I mean, I understand if we have to buy all kinds of customized hardware, that could be a very large expenditure. But if I buy you your laptop or your desktop computer as a capital expenditure, once that's done, the real cost is in the salaries of the people that I have to pay for. I'm going to buy you the software tools and all that stuff. Well, then the waste to eliminate would be the waste of underutilization. If people sit around idle, then that feels like waste. And if I'm a manager and I'm being measured on how utilized do I keep my people, I might look bad by comparison if my people aren't fully engaged. Fair? You think there's other ways? Oh, we're coming to that. That's what this whole discussion about. You said wait time. Hold on. See, for us, the problem is we're focusing on a waste that we can see, not the waste that we can't see. The waste that we can't see very easily in product development is inventory. Inventory, work that has gotten blocked, to your point on wait time, right? So, and that work starts building up in queues all over product development. The issue is, I mean, if you think about manufacturing, let's use this as an, imagine this for a moment. I design a product I want to manufacture. I order a truckload of parts. The parts show up at my manufacturing plant. They're unloaded onto the floor. The truck leaves. I now own the parts. Let's say I change the design of the product so those parts don't fit anymore in my product. What do I do with the parts? I own them. Truck's gone, right? I own the parts. Scrap them. Yeah, sell them on eBay for pennies on the dollar. Maybe I could rework the parts so that they might fit. Oh, I got a better idea. Let me compromise the design of the product so I can use the parts I've already purchased. Can we agree that once I take ownership of the parts, if I change the design, I will incur one or more forms of waste, potentially to the tune of 100%? All right. That's exactly the problem we have in product development. It's just our inventory is harder to see. In manufacturing, the inventory is both physically visible and financially visible. It's physically visible in an obvious way. I can go touch it. It's sitting there on the floor. If I have more of it, I can see it. It's building up on the floor. It's also financially visible. Hey, CFO of a manufacturing company, how much inventory is in the factory this week? This guy's going to give me an immediate answer to that question. Why? It's a critical variable in manufacturing. They track it. Neither of those characteristics are true for us. Our inventory is both physically invisible and financially invisible. It's physically invisible because most of our inventory, bits on a disk, the code that's out there, the test cases. I mean, we could print that stuff out and put it into a filing cabinet, makes it a bit more physical, or hang some Post-it notes up on the wall. But I'm sorry, nobody's going to confuse my Post-it notes on that board with that stuff over there in manufacturing. It's not physical in the same way. It's also financially invisible. Hey, CFO of a product development company, how much inventory do you have in product development? None. No, look at the balance sheet. There's no line item for inventory on the balance sheet. Wrong. You have inventory all over the place. The problem is, how do you manage what you can't see? So what do? We manage what we can see. And it leads to this problem. This is the one slide I said that was the same as for people who were here in my class on Tuesday. Watch the baton, not the runners. Let me tie all this together now. If my goal is to eliminate waste, if I hire someone to do testing, and I pay them 100% salary, and I assign them to a project, and they're only utilized 60% on that project, it would appear that I have a 40% underutilization waste. If I measured on that, that looks bad. So you know what I'm going to do, right? I'm going to take that person and do what? Yeah, assign them to the second project. Well, they need them 30% of the time, so now I got them up to 90%. That worked so well the second time, I'll do it a third time. Congratulations, clever me, I now have the tester at 100% utilization. I feel good. I pay him 100% salary. I got him 100% utilized. At what cost, though? Right? You're going to see how this plays out in teaming very, very quickly. Let's apply that strategy to the 4x100 meter relay race at the Olympics. On the strategy of let's keep them 100% busy. If I applied that strategy to that race, first observation, very inefficient race. No, it is, right? I pay those ladies 100% salary. I expect them to run 100% of the time, but yet each one runs 25% of the time. I feel like I have a 75% underutilization of my runners. And of course, they'll look at me and go, yeah, what do you want me to do when I'm not carrying the baton? I don't know, like run up and down the stands over here. No, better yet. There's another racetrack right over there. Run another race over there while you're waiting for the baton over here. Clever me, I've eliminated idle runner waste. Missing the entire point, though. In that race, you don't win the gold medal because you kept your runners busy. You won the gold medal because you got the baton across the finish line first. leading to the observation, we are watching the wrong thing. In that race, you don't watch the runners, you watch the baton. Now, if the baton ends up on the ground, you have a problem. All right, you won't win the gold medal. Let me translate. Baton, that's the work that we have to flow across our system, our collection of teams. If that work gets blocked and it's sitting in somebody's queue waiting for them to do it, that's the inventory that's building up all over the place. We are no longer advancing the work towards the customer. It's waiting. It's blocked in a queue. Right? Now, my guess is if most companies do a value stream map of how their work flows across their current system, the way they structure the teams, you'll find that 85 to 90% of the time, your batons are on the ground. They're not flowing. I'd like to suggest that might not have been the economically sensible way to have structured your teams, to have your baton sitting on the ground 85 to 90% of the time. The real cost of that is the delay cost, as he was alluding to. Right? When the work doesn't flow, it takes more time to get the product out to the customer. There's a cost associated with the time. So clever us. We drove people to 100% utilization, so we eliminated one form of waste, and we made another form of waste go up, the delay cost. When you compare these two, you are likely to find they are in totally non-comparable units. One is like in tens of thousands of dollars, the other is in hundreds of thousands to millions of dollars. We traded off the wrong thing. Why? Because we can't see the invisible part, the inventory. You have to measure it. Go to the curve for a second. That's borrowed from queuing theory. You don't need to know anything about queuing theory to know the graph is correct. All you have to do is own a computer. What happens when you run your machine at 100% CPU, 100% memory utilization? Nothing happens, right? It grinds to all. The technical term is it's thrashing. You're trying to get more and more work done, nothing's happening. Why? Because you moved into the high queue state. And when you find yourself in that state, you realize there's not many things you can do. Waiting would be a dumb thing to do, right? You're going to open up Task Manager or something, start killing jobs, or reboot. The goal is don't let yourself get into that state. That's why guys who manage server farms for a living, no, you don't run your servers above 80% utilization. Why? Because you move on to the exponential part of that curve. The math is simple. Every 5% increase above 80% doubles the queue size. 80 to 85%, double it. 85 to 90, you double it again. 90 to 95, yet again. So this is the inventory building up. So if you're a team, and everybody else, if you're a team and everybody's dropping work into your backlog as it's queuing up, everything starts to slow down. Everybody starts waiting a long time. You know it's true, right? If you go into Starbucks and there's 3 people in queue in front of you, at 80% utilization, you can all do the math. It's taking them about 2 minutes per person. There's 3 people in front of me. Okay, I'll stay. You go in and they're 99% utilized. They got 19 people in front of you. You do the math again, and you probably turn around and you walk out. We have to capture this waste. We have to manage it. So when you structure your teams, one of the first things you're looking at is, did I improve or make worse my inventory situation? Please.
Can you give an example of how structuring based on features as opposed to components is going to change that?
That's the next part of all this. Yeah, so is there an example of how to lay this out? I'm going to walk very quickly. I'm going to do a couple more of the principles, and I'm going to walk through, here's feature teams, here's component teams, here's the pros and cons when it comes to these principles we're talking about, and then at the end I'm going to talk about a blended solution, which, by the way, is where most companies end up anyway. So that's where this is all going. Cycle time, right? Think of cycle time in this context. You have the idea, or you get the problem statement, you click the stopwatch. Time is now progressing, right? When you actually deliver the solution, you click the stopwatch again. And that's what we're looking for. Did the way you structure the system, did it improve cycle time or did it hurt cycle time? Does it take longer to get something out to a customer? Let me give you an example. This is a form of a value stream map. It's not exactly in the value stream language, but you can draw them any way you want, right? So we're grooming a feature, and then we split it off into 3 different teams. They converge back together because there's only a single art team. Think of that as one of our discipline teams that we talked about before. So each of those teams might need artwork, and they have to farm that piece out to the art team. When the art team is done, it can come back to the development teams. Then it goes into integrate and test, and then we deploy. Let's say that an organization might have that structure. That's how they flow work across their system. The numbers in red represent waiting times, right, at various steps in the process, right? So, 2 days waiting between the idea being generated and we start grooming the idea down. Once it's groomed, it sits in queue for 2 weeks before we actually give it to the development teams. Maybe that's one sprint, right? It waits for a sprint and then it gets allocated to the teams. They're working, say, 3 weeks here. There's a 6-week wait in front of the art team. We'll talk about that in a moment, right? And so on. You get the idea across the grid. The green times represent value-adding work. The times that the team is actually doing value-adding work, meaning the batons are moving. Green, baton moving. Red, baton on the ground. When you do the math, sum up all the greens and the reds, in that picture, there's 6 weeks of value-adding work time. There's 39.4 weeks of total cycle time, right? End-to-end across, 15% process cycle efficiency. So the batons essentially are on the ground 85% of the time in this picture, because only 15% of the time did we actually do value-adding work. This is what I always find funny. I'll go in to visit a company, and some senior manager will pull me aside and say this to me: I sure hope when you're done that the development teams are able to function 10% more efficiently. I'd like you to increase the velocity of my teams by 10%. And my comment back is, really? Are you sure that's really the problem you want me to help you solve? Let's just do some really simple math for a second. If we squeezed a 10% improvement out of the value-adding time, that would be a 1.5% overall improvement in the process. If we squeeze 10% of the waste out of the system, you'd immediately get an 8.5% increase. Almost an order of magnitude difference. Really? Most companies, the problem isn't the efficiency of the individual team. It's they've structured the system so poorly, they block themselves at every turn, and their process efficiency is so low. If they focused first on the system, that's the low-hanging fruit. Not how do I squeeze more out of my team, work them more hours, stuff like that. Fix the system, you'll get an immediate and demonstrable increase in productivity. All right, so we have to measure this. Otherwise, how would you know what your numbers are? So I hope when you go back to your office, first thing you do is you're drawing a picture like that to figure out what is your real number. All right, we've talked about cost of delay. Let me put it into context. So in that picture I just showed, what if you have to wait 6 weeks for the art team to do it? Whatever, you put something in their queue, from the time it goes in the queue to they start working on it, it's going to take 6 weeks. That's just the time it requires for them to get to it. What if that delay could be eliminated by taking the artists and assigning them out onto the individual teams? Right? Now we're talking about team structure choices. Did I have a discipline-specific team called art, to which all art-required work goes to this team, gets put into queue, or did I, in a sense, take the artists and assign them out onto the equivalent of feature teams, right, to do the work? Well, the only way you can do that is to do the math. First question, what is a 6-week delay cost in lifecycle profits? If I tell you right now, I'm just going to delay whatever you're working on right now by 6 weeks, you should be able to think about that and say, wow, what's the cost of that 6 weeks in terms of overall lifecycle profits? Lifecycle profit being the total profit potential of the product over its lifetime. And accounting might define that to be a fixed number of years, 5 years, 10 years, but you run the math. Versus the extra cost of maybe hiring more artists and putting them on to individual teams so that we didn't experience the 6 weeks. You could start comparing the two and say which was the more economically sensible choice. Just to say, well, art has to go to the art team, maybe. That's certainly one way to do it. But if you have this delay time of 6 weeks, that may not have been it. Please. It might have. So the comment was, what if we hired more people? So I made the observation, maybe we would have to hire more people, right, if we wanted to put an artist on each team. Her comment is, wait a minute, why don't I just hire more artists and put them on the art team? Fair? So once again, we could look at both models and say, if I added 2 more artists to the art team, what does that do to lead time, right, in terms of the art? Does it take it from 6 weeks to 4 weeks? That might be a good move. On the other hand, what if I put an artist on every individual team where there was 0 delay? 0, right? I mean, the moment you needed the artist was available to do the work, and there was no delay in that respect. So we wouldn't know universally until we looked at the numbers. And by the way, we may not have to add any artists at all if we just took the artists and put them out. But typically, most organizations have what I call a specialty skill. I define that to be whatever you have the fewest of. Whatever you got the fewest of, that's your specialty skill. And those people tend to be multi-project, right? We'll talk about the consequences of that too. All right, organize the teams to validate important assumptions first. Think about how you structured the teams and ask yourself the following question. If I use that team structure, does it help me validate important information quickly, or does it defer the validation of important information until late? The economics favor fast feedback, right? That which I learn early is more valuable to me than that which I learn late, because I can act on it sooner. I mean, take for example, what if we had 3 teams? Each team's building a component. We know at some point those components have to integrate, right, to create the product that we want to deliver. If our motto is that we're going to, maybe there's even an integration team that tries to do this late. The problem is it's never really kind of gone together that simple for me. Those Lego bricks just kind of snap together. I mean, it never has worked out all that well. So when we do this late, the only thing we don't know is how long we're going to need in the test and fix phase, right, when they don't actually integrate. Well, that's a rather bad time to learn that things don't integrate late. So maybe we structured our system to learn a very important piece of information at the worst possible time we could ever learn it, late. Maybe we should have structured the teams differently. As I said, in this section, I'm just laying out some core principles that will guide the evaluation of feature versus component teams, and now I'd like to start that. Everybody good so far? Cool. All right, so component teams. We talked about what they were. Let me give you an example of, here's the classic problem with component teams. I promise I'm going to balance this discussion. I'm going to talk pros and cons of both approaches, because as I've already stated, I don't believe in the dogma that one is universally good and the other is universally bad. Imagine you had a product backlog. It has features in it. So that product backlog in the upper left has features. Now, let's say that we have created component teams. That's how we chose to structure our system, which means a feature out of that backlog might span 3 component areas. So what do we have to do? You have to take the feature out of the product backlog. You then have to split it into its constituent component pieces, and you have to farm those out to the individual backlogs for the component teams. The nomenclature is like component area number 3 product backlog. So the product backlog for component area number 3. Okay, fair enough. So what happens? Each of the component teams builds its piece, routing team over here, other teams, right? They build their piece, and when they're all done, they integrate their pieces together. If this were Scrum, maybe doing something like a Scrum of Scrums to help oversee the collaboration of that work, and then deliver it back. At this scale, no harm, no foul. It probably works just fine. A scale of 1, sure. They could probably figure out how to do that and make it work. There's a little bit of magic in here. I mean, who went ahead and figured out how to break it into the 3 constituent pieces? I don't have a team up there. I have teams down here, right? But I'm sure we could have figured that out. Maybe some architect got involved and said, here's how you'd split it, right? So there's some way we could do it. Fair? That's scale 1. What if we just go to scale 2 for a second? Now I have 2 products. So we built 2 products in our company. Each product has features that span across the 3 component areas, which means when I take a feature out of each product backlog, I am now obligated to break the feature down into its constituent component pieces and put them into the respective backlogs. All right, so remember, each of these backlogs has a product owner. Every backlog has a product owner. Someone's got to prioritize the list, right? So you're the product owner of a component area. Now you have 2 things that are competing for time in the upcoming sprint. And you have to decide, in what order should you do them. Do them in sort of the correct order, and make sure you're also integrating with the other teams that have to do their things and return everything back to the individual products at the right time. At scale 2, probably still solve the problem. Let's make it more interesting. Scale 15. I won't even attempt to draw the picture, right? You have 15 different products you're working on. Each of them spans all the component areas, or at least those 3. Now I have a question for you. You're the product owner of one of these component areas. You have 15 competing requests to do work in your component area this sprint. How will you simultaneously prioritize those 15 competing requests, do them in the right order, while at the same time coordinating with every other component team that has to do their 15 competing requests in the right order, get everything magically integrated at the right time and delivered back to the people who need them. Yeah, that's our scheduling policy called noisiest person first. The guy who screams the loudest in your face, you just do their piece to shut them up, right? I hope I've now illustrated at scale. Some of you live this every day, so this isn't anything new to a number of you, right? You live it every day. And since so many companies do it, there must be a solution. There is. Baton, ground. Let's make sure we're clear on what I mean by that. Here's what it sounds like. Hey, did you get my feature done? No. Well, why not? Well, I had to break it into 5 pieces and farm it out into 5 different component teams. 4 of the 5 teams actually got their pieces done, but the 5th team didn't. Well, why not? Well, I asked them that, and they said that they had 14 other competing requests for work to do that sprint, and ours just wasn't the highest priority piece of work. But don't worry, they said they'll eventually get to it. Sorry, precisely how is it that you run your business on eventually? We might get the feature. See, the problem is, whereas with a single team, we had 1 point of failure, now we have 5. You've now multiplicatively increased the probability you will drop the baton. This is why in large organizations, especially ones that have heavily focused on component teams, their batons will be on the ground over 90% of the time because they block each other at every turn. They structured the system in an economically nonsensical way. And they did it for particular reasons we're going to talk about in a moment. I thought I saw a hand. Please. Right, but see, what happens when the question earlier came up, the components are reused across all of our products. Routing is a component in every GPS that we sell. How do you deal with it? So that's what we're trying to attempt to deal with here. All right, so I think everybody's clear on the issue. I mean, think about that prioritization issue we just talked about. So how will component teams do it? Maybe your experience is similar or different. This is how I see a lot of times it happens. They may choose whatever's fun or easy. They got 15 items in the backlog. Hey, it might be their preference to do it that way. Or they could do it on technical priorities. Why didn't you work on my piece before you worked on her piece? Because technically it made sense to work on her piece before it made sense to work on your piece. Because now we can get your piece done faster once that we've done her piece. So they could prioritize it based on technical priorities, which, by the way, may not at all align with business priorities. My project was the $1 billion project, hers was the $1 million project, and they just made a decision that sub-optimized the economics of the full system. Local decision, right? They could just be unavailable. That team is currently very busy. Whatever you need them to do right now, get in queue, and in 6 weeks, that art team will come around and they'll do the work for you. They're just simply not there, right, when you need them. Or, as we already said, noisiest person first. Right? You know, whoever's screaming the loudest, we just do their piece first because I just don't want them screaming at me anymore. I think it's common enough. So we have issues with prioritization. Hello? Not sure why that. Swap to a different one. Okay. Oh, hardware difficulty there. We'll advance manually for a moment. Coordination costs. Think about the coordination costs under this type of model, a component team only model. Well, first, there's a lot of planning and handoffs, right? You're breaking all these things into the little pieces and you're throwing them out to different teams. Who's orchestrating that all that work is actually getting done at the right time and all coming back together? I got individual product owners at the component team level. Was there a project manager or something above all that? It's not exactly clear. At scale, as I pointed out, the dependency management part here becomes intractable. Right? At scale, you can't solve it, so this stuff drops on the floor. right? Because we can't get it all done. And it really does favor a more low bandwidth way of communication. We had said we favored high bandwidth forms of communication. Typically, component developers create some form of API doc that they share with other component developers and say, program to that. Documentation, Agile does not consider documentation to be evil. It is, though, a low bandwidth way of communicating relative to other options you might have. So we have that. We said we favored fast feedback. That was one of the core principles we talked about. I don't get that here. First, it's a much more predictive model. I have to predict the API on the first day when I have the worst possible knowledge of the system I'm about to build. I could be wrong on that, but I don't get feedback very quickly. I got to wait till people build their component, and I try and bring the stuff together, and then I find out late none of it's working. That's a costly mistake to have made. I also get external feedback slower. Why? Until I put all the pieces together and actually show it to a customer to get their feedback, I don't know whether or not I built anything that truly meets their needs. And typically, we're on the dashed line in that example because we bring things together late, so we're not delivering value until later in the process. That has some unfavorable economic characteristics to it, right? When you start looking at structuring teams this way. It also has a way of limiting learning. Right, if you're inside your little box working on a component, some people feel like, I'm just stuck, right? I'm working on this component. I'd rather broaden my experience base and get out. Other people might say, I love it. I love specializing. I only want to be a routing guy. I just love routing, and I just want to spend my life doing routing algorithms. Okay, hey, don't fault them, right? I mean, that's their preference for doing it that way. So, when you focus just on components, you could have radically different opinions in the people who are working on them. Of course, that's a very risky thing to have done. I have 8 people who know routing in the entire company. I think I have a new company policy. Those 8 people aren't allowed on the same airplane at the same time. Seriously, right? I mean, your risk, if you only have a couple, think about it right now. If in your company, those specialists we talked about before, if you got 2 guys that know some core system, those 2 guys can't travel together, right? That's a real risk. What if they retire or quit or something? Now what? As an organization, it makes no sense to have that kind of expertise in such a small number of heads. It can be a little harder to see the whole, right? We got teams that focus on their individual component. Oh, by the way, they're building the best components ever. But when they try and bring it together, I still have a poor product. I think everybody knows this, right? From systems theory, bless you. If you optimize the individual components, you're almost guaranteed to sub-optimize the system, right? Local alignment trumps local excellence. I'm more interested in, does the system and its components line up well versus did you build the best possible component you might have ever built? Because building the best component that doesn't easily integrate with the other components puts me in a bad position. So it's harder to see the whole at times when you're focused on the component level. Of course, there are some desirable properties of component teams. Conceptual integrity. We talked about this before, right? You guys know this code. I trust you. You're the 8 people who know routing, right? I don't want just anybody in there mucking around because they could screw it up and things start breaking all over the place. That's compelling. I want congruity. I want consistency. I want this coherency in the component. Who doesn't? I mean, who wouldn't want their component to be highly coherent, right? Very consistent, reusable too. We'll talk about that next. The problem is I want integrity both at the component and the full product level, and I think we have to buy into this. This is the comment we were just making. Just because you have conceptual integrity at the component level does not guarantee you'll have it at the product level. So we might indeed achieve exactly the goal we were shooting for, which that component is well developed, well designed, right, coherent internally, but yet I still don't have a product that functions the way I need it to. But I think a lot of people, when they go to component teams, this is one of the principal things they're looking for. Let people trusted in that asset base go into that asset base, make the changes. Reuse being the other obvious thing, right? I want to use the thing in 4 different systems. I don't want each system building that same piece of functionality. I want to reuse it. I mean, who wouldn't want to do that? Anyway, in my old object-oriented day, I come out of the small talk world, so we were all about reuse, right? I mean, but when you start thinking about that, everybody wants reuse. Who would like to build the same thing twice? You'll build something more interesting the next time, right? So sure, I want that. So go to component teams then, if you want that. Maybe, right? I think there are other ways we can achieve it, but certainly conceptual integrity and reuse are the two big advocates for why you would structure around component team boundaries. I really want to reduce the quantity of technical debt. My fear is that if I let every feature team walk in and change the code in a component area, I'm going to start to accrue high levels of technical debt. I don't want that. And I don't want that, right? And neither do you. So our goal is to figure out, is there a way that we can balance a system with blended teams where we get these properties? Comments so far? Okay. What about feature teams then? All right, well, the first argument will be the lack of conceptual integrity, right? When I let all those different teams go into the routing code and mess around, I'm not really sure I have a coherent routing module or component anymore. It's starting to look a little flaky there, a little wavy to me. True, if people don't know what they're doing and they're in that code messing around, absolutely. We've all had it happen, so we know it's true. The other thing is, think about what it means from a technical practices level. What if I said this to you? All of the feature teams in this room, you are all allowed to go into that component, go into the database where the code is stored, you're allowed to make changes. Well, you got the first thing, well, how will I manage concurrent access when I have 10 different teams simultaneously hitting on the same code base? Meaning, if you're going to go to a feature team model, it does imply a certain proficiency at the technical practices level to make it work. What about continuously integrating your work? Right? I mean, if everybody's making changes in real time in here, are we continuously integrating across the various teams that are doing it? This is one approach for avoiding that downstream integrate late problem. Well, if I don't integrate at the end with a special integration sprint or iteration, when do we do it? I don't know, like all the time? At all reasonable points in time, even intra-sprint. Oh, but I mean, once again, that applies a certain level of technical proficiency to be able to do that. So there's a technical practices issue if you're going to have all feature teams out there. You could simply have a lack of knowledge. When you think about it. First, if you're a feature team, you need sort of deep domain skills. Here's a feature in this given domain, build the thing, right? It kind of presumes you at least know something about the domain in which you're operating. But it also starts to imply a fair amount of deep technical skills because I have to work in these various areas. And then when you start putting it all together into a large system, are you going to have your feature teams know how to work across all those different components in that system? Is one team of 5 to 9 people going to be knowledgeable enough to work across that entire system? That's an issue, right? I mean, that could be a very large system. I mean, some of us work on big stuff. I mean, when Chad was up here, what was he saying? 100 teams and 300 teams? John Deere works on some big stuff. What about the non-functional requirements? Who owns those in a feature team only world? Things like, oh, hey, the system has to scale to 10,000 concurrent customers. Okay, who's ensuring that that's actually happening? Who designed for that? When did we test that? Right, or we have to reuse or conform to certain policies, or maybe we have an SLA with our customers, or internationalization. Who? In a feature team world where everybody's in components touching them, who owns this stuff? An issue that we had better work out, because someone better. And what about that whole team longevity? I had offered up the observation that in Agile, the unit of capacity, when you calculate WIP limits, is the team. So you keep your teams together so you have these known units that you can use for planning purposes. Well, I assigned Team A, feature Team A, to work on the first product. We're done. Nice job, by the way. You did a good job with it. That product's done. Question. Can I just move that team, because that's what you want to do, move the team as a unit to the next piece of work and have them do the next piece of work rather than bust them apart and recompose a new group instead of having a team? Maybe. But this is where you have to ask the question. In our organization, is the work of sufficient similarity where I could take a team that could work on product A and assign them to work on product B? Or does product B require a radically different set of skills in order to get the job done? You have to factor that in, right? But as we said before, there can't be one universal decision here because all these factors vary company to company. So we have to factor in team longevity. Do it manually then. And then, of course, there's the issue of organizational resistance. A lot of organizations, not all, but a lot today, they have these, sorry, I'm going to refer to them as fiefdoms. Some manager owns a group of people that work on certain things. Maybe they're functional areas, component areas, and they don't want to change. Right? I own a fiefdom, and I own those people, and they do the work I need them to do, and I tell them what to do, and it's the way I want it to work. Well, if you're going to reorganize into feature teams, it's not going to look that way. And there can be a fair amount of resistance to actually making the change to move over to that. I wouldn't underestimate that. And certain companies I've been with, I'm not sure they're ever going to get past that problem. Cultural thing. All right. Now, how do we put it all together? Last piece. And then we'll have time for a few questions. Blended examples. All right. Now, I said earlier that I have not seen a large company be successful in this place and not have a blended model. I think if they had pure feature teams 100% of the time, that probably would not have worked out all that well for them. And certainly having pure component teams wouldn't have worked out well either. My experience, it's just an observation, yours may differ. Since I visit a lot of companies, typically 2 a week, most large companies that I visit have made the decision for most of their teams to be component teams with the occasional feature team. And they pay a heavy penalty for that decision, like batons on the ground 90% of the time or more for reasons already stated. Right. So how could we approach this? Well, there's a number of patterns. Now, I'm going to restate what I said earlier. There is no perfect solution here. There are only trade-offs. Your goal, use the economics of your situation to make the trade-offs. Let me make this clear why this is important. Why universally one versus the other isn't always right or wrong. In Nashville, I'm pretty certain that the fire stations are distributed throughout the city. I don't know that for a fact, but I'm pretty certain about that. Why? Because if they centralize one fire station in the middle of Nashville and a house starts to burn on the perimeter of the city, it will likely burn to the ground before a fire truck can get out there, and people might die, meaning the cost of delay is too high for centralizing. That would be a component team, by the way. All the firefighters in one component in the middle of the city. So what do? We distribute them out into separate firehouses. That would be feature teams. Put the artists on individual teams. The economics of that choice makes sense, right? Because the cost of delay by not having done it would be too high. On the other hand, I'm guessing again, but I will assume that in Nashville accounting, the accounting department is centralized. They have not distributed the accounting department throughout the city. They might have payment offices distributed around the city, but accounting as a function is likely centralized. Why? It makes sense to centralize it. The economics of having centralized accounting makes sense. So sometimes we distribute them out, sometimes we centralize them. You can't just universally say one is the right approach and the other is the bad approach. What you have to say is look at the economics of the choices and say, would it have been better to have centralized it or would it have been better to have distributed it out? Once you answer that question, you're in a leveraged position to make a good choice. So one way we could approach this, you recall in the 2 previous pictures that looked like this, we had features that were being broken into their constituent component pieces and put into product backlog. The first thing you'll notice that's different in this picture is say hello to the feature team. The other pictures didn't have the feature team. So here we do. So notice what's going on. It's pretty simple. We take individual members of component teams and we move them up to be a member of a feature team. So now I have a feature team that has all the skills necessary to get the job done. It's cross-functionally diverse and sufficient per our requirement for what makes for a good team. So I move them up. Now I can take a feature off of that backlog and I can give it to an individual team, and they have on that team all the skills to get the job done. And now these people up here have 2 responsibilities. They are both pollinators and harvesters. They pollinate the feature team with knowledge of the component area. And they're harvesters because they can take back changes that need to be made. Right? This guy can come back over here and go, hey guys, look, I need to make a change in the component down here in order to be able to complete some features that we're working on this team over here. I'd like to run those changes by you for two reasons. First, I want to make sure I'm not going to stomp on anybody's toes when I do it. And second, maybe one of you has already done it, and I might be able to leverage and reuse what it is that you've already done. So in that respect, they harvest back changes they're going to make. So we could start blending our model to look like this. So now we have our features team back, and these guys are assigned to that team. And if I had a specialist that I didn't need for, say, a couple sprints or so on a team, I wouldn't ask them to be there. Because if you're on the team, that means you have to do things like show up at the daily scrum. Right? If they're going to report like, I did nothing yesterday and I'm planning to do nothing today,